Hi, welcome to this tutorial on the normal distribution. Now in this tutorial what I want to show you is how we work out the probability of being more than an observed value x where the observed value x is less than the mean mu. And the best way of doing this is by way of an example. Now here's the example which I'll read out to you. A carton of orange juice has a volume which is normally distributed with a mean of 120 milliliters and a standard deviation of 1.8 milliliters. Find the probability that the volume is more than 118 milliliters. Well, the first thing I want to do is to define a random variable x, and that random variable will be, let x be the random variable volume of the carton in milliliters, where x is normally distributed. Remember, we have two parameters, the mean mu and the variance sigma squared. Now the mean then is 120 and the variance is the standard deviation squared. Standard deviation is 1.8, and so in this particular example, rather than work out what 1.8 squared is, I've just left the variance as 1.8 squared. Next, I'd want to draw a sketch of the distribution, label the axis x, which represents the volume of the carton in milliliters, mark in the central value, the mean here, which we know is 120 milliliters, so have 120 there, and then the observed value 118 milliliters, which we'll just put over here. That's 118. Now it's an observed value, and the standard letter for observed values is a little x when the random variable is capital X. We're interested in the volume of being more than 118 milliliters, so that means it's represented by this shading over here, this area. So just draw that in. Now in order to find this area, this probability, we need to standardize the distribution. So what I do is draw another normal distribution below, label it z, z being the standardized variable, where z follows a normal distribution with mean 0, which we mark in, and the standard deviation for this distribution is 1, so the variance would be 1 squared or 1 still. I need to now find out how many standard deviations 118 is below the mean, and to do that I project that straight down onto the standardized graph, label this z, and that number of standard deviations which is given by z is given by the formula which you should already know, z equals the observed value minus the mean mu all over the standard deviation sigma. So if we put our values in, the observed value is 118 minus the mean mu, which is 120, all divided by the standard deviation sigma, which is 1.8. So just put the 1.8 in there, and if you work this out, you'll find you get this equals minus 1.111 and so on. So that's minus 1.111 standard deviations below the mean of 120, that value of 118. Okay, so we now need to try and work out that probability. We want the probability that x, the volume of the carton in milliliters, is more than 118. And that's going to be exactly the same as working out this area here, which is the probability of being more than a z value of minus 1.111. So just write that in as z being more than minus 1.111 and so on. Now we need to use the cumulative normal probability tables, and we'll bring those up here. Here's an extract. Now you'll find these tables in any set of formula tables or possibly in the back of statistics textbook, and what we have here is z values, and phi z, this function phi z. Phi z is the probability of being less than any given value of z. But the only problem is that the tables that you'll generally find you have just give the area or the probability of being less than a z value, which is to the right of 0, a positive z value. And here in this example we've got a negative value. So to get around this problem, let's just draw a line down here and border this off. What I can do is just consider the standardized distribution. We've got this value of z being minus 1.1 and so on. I'll just write minus 1.1, and we're after this area here. But what we can do is mirror this value into another distribution, another standardized distribution, mirror it across to the other side, look at this value here of plus 1.11, and that area would be the same as this area here. So in other words, this is exactly the same as working out the probability that z is less than 1.111 and so on. And we tend to call this phi of 1.111 and so on. And we can use the tables now to work this out. All we need to do is look up the z value of 1.111. Now here's the z values, but unfortunately these tables are a bit restricted. We've got 1.11 here and we've got 1.12 here. So we tend to take the value that's closest to 1.111, and that would be this one here, 1.11. And the corresponding phi of z value is here, 0.8665. So the answer then is 0.8665. But bear in mind that these tables are restricted. They're four-figure tables. There would have been values behind this, and so really we ought to round this up, say, to 3 decimal place to guarantee an answer which is going to be accurate. And so for 3 decimal places this would be 0.867, and then put the 3 decimal places in. And there you have it, the probability then of being more than 118 milliliters. So hopefully you can use this example to model problems where you've got to work out the area to the right of a observed value which is less than the mean. Okay, and that brings us now to the end of this tutorial.